In this recording, we're going to learn how to solve equations with rational exponents. Basically, what that means is an equation that has a fraction in its exponent, something like this. So if you see a fraction in the exponent, how are we going to solve this? Let's do a little warm-up to find out. You're going to need a graphing calculator of some sort to be able to do this warm-up. As I put down at the bottom of the screen, if you don't own your own graphing calculator, that's no problem. Just Google online graphing calculator. In fact, that's how I'm going to model it here in the video. So let's look together at this graphing calculator. We're going to put in the following function. In parentheses, so I can get my parenthesis here, x to the exponent. I got to remember what I got here. 2/3 is on the inside. Okay, so I can create a little fraction here by just doing 2 divided by 3. Okay, 2 divided by 3. Then click on the outside and then create an exponent. And this time we want 3 divided by 2. And it makes that V-shaped graph, which we recognize as the absolute value. Okay, so you can do the same for that. You can just copy that, and paste that down in here, and then edit it to reflect the remaining graphs. So you want to do this second graph, the third graph, and the fourth graph, either on your graphing calculator or on the online version of it. And after you've done so, play the recording. Okay, so hopefully you've graphed each one of those. Now, if you're on your own graphing calculator, read what I've got in green here. It says you can deactivate a graph of a function by unhighlighting its equal sign. Just clicking on its equal sign will get rid of the graph, and you don't have to clear it. Just have it hidden for a moment. Okay, so I'm going to look at this online one right here. Okay, so the first graph, 2/3 raised to the 3/2, made the V-shaped. And so did 4/3 raised to the 3/4. So again, you can turn these graphs on and off just by clicking the color next to it. Now, in contrast, 3/2 raised to the 2/3 made just a line y equals x for the positive values of x. And same with 3/4 to the 4/3. Because it would seem like any exponent raised to another exponent, we multiply them, right? And something times its reciprocal always makes a 1. So each one of these should just make an x. However, the ones with certain exponents made just the ray, and other ones made the absolute value. So let's conclude. Back over here. What pattern did you notice? What conclusions can you reach? Paying particular attention to whether the exponents are even or odd. Okay, so why don't you make a little sketch next to each one of these. Write this all down in your notebook. Make a sketch next to each one of these. We've got these two made the absolute value, and these two just made the ray, okay, y equals x. What can we conclude from that? Hopefully you recognized that when the exponent on the inside has an even numerator, like a 4 or a 2, when we multiply it by its reciprocal exponent, we get the v shape, the absolute value. But when it's an odd, just like if we cube root a cube, we don't get the absolute value, we just get y equals x. So let's write that conclusion. If the inner exponent has an even numerator, you get the absolute value. An example would be 100 over 7. If you raise it to the 7 over 100th, you would get the absolute value. Otherwise, you don't. You just get y equals x. All right, so let's apply that to solve a couple of rational equations with rational exponents. So in this particular example, let me just make this a little more viewable for you. There we go. In this particular example, we've got a rational exponent, and we're concerned about extraneous solutions. So as you're writing this question down, please make the note that we're going to want to check always for extraneous solutions. Okay? There also may be more than one solution. So when we have an equation like this, we should always be thinking about how can we get rid of the thing that we don't like. We don't like this 2/5. So how could we get rid of it? Well, we could multiply its exponent by the reciprocal exponent, because 5/2 times 2/5 is just a 1, right? So that'd be n. Except we saw before that when you have an even exponent inside in the numerator, that gives us the absolute value graph. So we've got the absolute value of n equals, and of course whatever we do to the left side, we have to do to the right side. So we have 4 raised to the 5/2 exponent. Right? So let's make a little note to ourselves. Raise both sides to the reciprocal exponent. Make that note. That's how you solve an equation that has a rational exponent. Key step there. All right, so we've got the absolute value of, well, we have to figure this out. We can use our calculator, we can use our head. 4 to the 5/2 exponent. So if you don't know what the answer is, just pop that in your calculator. 4 to the 5/2 turns out is 32. If we take the square root of 4, that's what the half does, the denominator, and then that would be a 2, and then 2 to the 5th gives us 32. So the absolute value of n equals 32, therefore n equals plus or minus 32. We do need to check these apparent solutions to see if they actually check. So we'll do our checks. So we'll check n equals negative 32, and we'll check n equals 32 just by subbing in. So we go negative 32 in parentheses raised to the 2/5 power. We want to see if that works out to be 4. And the same thing over here, 32 raised to the 2/5 power, and see if that equals 4. Just pop that in your calculator. Sure enough, 4 equals 4 there. 4 equals 4 there. Okay? If you want to do this without a calculator, you'd have to do the denominator first. I think it's easier that way. The 5th root of negative 32 is a negative 2, and negative 2 squared becomes a 4. Over on this side, the 5th root of 32 is a 2, and then 2 squared is 4. All right, so let's make it slightly more complicated here. Let's now consider an example where we have an extra number in there, a 3 in front. So there's a 3 in front. I knew how to solve it if 3 wasn't there, so how should I solve it now? There's a 3 there. Get rid of the 3, right? So jot down this example, and let's do what we would always do. Let's get rid of the stuff that bothers us. So the 3 bothers us there. Let's get rid of it. Right? And so when I divide both sides by 3 to isolate the base, the power, okay, we have an expression that equals w to the 4/3 equals 16. Okay, so let's make a note of what we did here. Isolate the power first. This power is the expression with an exponent. So isolate the power first. Right, and the power, just so you can clarify, what that is the expression with the exponent. And you guys know what to do at that point. Once we've got a 4/3, we just learned about how to do that. We want to get rid of the 4/3 exponent or power by raising it to something that is its reciprocal, because 3/4 times 3/4 times 4/3 makes a 1, right? Of course. However, we need to think about the fact that this is an even exponent in the inside, and therefore this is going to become the absolute value of w. We're going to do 16 to the 3/4. I'm having trouble making that 4 super clear. That's a little better. So 16 to the 3/4. 16 takes the 4th root of it. That's a 2. 2 cubed is 8. I think that's going to work out. You can confirm that with your calculator. So this is going to give us W equals plus or minus 8. Go ahead and do both those checks. So check that W equals 8 and that W equals negative 8. And that simply means sub it back in to the original equation in place of W. And then just use your calculator to confirm that it works. Okay, so in this case, we would get 48 with our calculator. And over on this side, I'm going to sub in a negative 8 for W and confirm that it works. And it does. Okay, so 48 equals 48. As long as you show the substitution and then evaluate on your calculator, the real key is to just verify that this all works out. Okay? Because sometimes it won't. Last example we're going to consider is this. Okay, in this example, we've got a couple extra pieces that we don't like. And again, we're always going to isolate the power first. Okay, the power here would be the x to the 3 halves. But, of course, we're going to get rid of this minus 5 first. Okay, we're going to add 5 to both sides. And so we've got here 4x to the 3 halves equals 108. All right, what should we do next? We've got this 4 sitting out in front. Don't like it. Let's get rid of it. We saw how to do so before. We would divide both sides by 4, and that's going to leave us with an x to the 3 halves power equals 27. Okay, see if you can take it from here. Okay, so hopefully you paused and worked this one out. If you haven't yet, please do so. Raise both sides to the reciprocal exponent, so to the 2/3 power. It's going to get rid of the 3 halves power. Now you've gotten in the habit of getting the absolute value, but we're not going to have that here because the inside numerator in the exponent is odd. So we simply get x. And when you raise 27 to the 2/3 power, I think it should come out 9. We just need to check one answer. So we check that x equals 9 by subbing in. So we got 4 times 9 to the 3 halves minus 5. And you don't have to show step by step by step, but we could here. That's going to be a 27 times 4 is 108 minus 5. It is going to work out. 103 equals 103, and you've got it. Thanks for watching. Try that quiz.